Okay, the integral of e to the 5z dz. So a function whose derivative is e to the 5z. It's definitely going to have an e to the 5z in it, but the derivative of e to the 5z is e to the 5z times 5. So I need a 1/5 out front here to cancel with the 5 that would come from the chain rule. The integral of sine 2 theta d theta. So a function whose derivative is sine would be negative cosine. So I'm going to have negative cosine 2 theta. But now let's think through working backwards. If I want to take the derivative of cosine 2 theta, negative cosine 2 theta, that would give me sine 2 theta times 2 because of the chain rule. So I have to put a 1/2 here to counteract that times 2 from the chain rule. Okay, the integral of x to the 3/2 plus x to the 2/3 dx. So I'm just going to use my power rule here. I'm going to add 1 to the exponent. So 3/2 plus 2/2 is 5/2. And then you're supposed to divide by the new exponent, but that's the same thing as multiplying by the reciprocal. And then x to the 2/3 plus 3/3 is x to the 5/3. And then divide by the new exponent or multiply by the reciprocal. The integral of 1 over e to the z dz. I'm going to rewrite this as the integral of e to the negative z dz. And then I'm going to think through, okay, a function whose derivative is e to the negative z. So it would be e to the negative z. It's going to be part of it. But now if I work backwards, if I say, okay, we'll take the derivative of e to the negative z, that would be e to the negative z times negative 1 because of the chain rule. So I need to put a negative out front here to cancel with the negative from the chain rule when I take the derivative. And then add my plus c.